Welcome to lesson 3.3, solving multi-step equations. So in 3.1 and 3.2, we've already looked at solving one-step equations. Now we're moving into lesson 3.3 with solving multiple-step or multi-step equations. So the rules are still the same, that we'll be using inverse operations. We want to think to ourselves, how do we get the variable alone? And we are working the order of operations, which I abbreviate or use the acronym GEMDAS. We are working the order of operations in reverse or backward. So when we are doing multi-step equations, what you want to keep in mind is that we have to deal with subtraction or addition first, and then we are dealing with the division or multiplication. So unlike the normal order of operations where we have to deal with multiply dividing first, now we are dealing with addition or subtraction first. So in A, B, and C, we're going to look at that idea to start. So in A, we have 4x minus 8 equals 24. So if I look at the side with the variable, I have multiplication, 4 times x, and I have subtraction of minus 8. So the first thing I want to do is get this minus 8 to cancel out or go back to 0. So I drew my line segment through the equal sign. Remember, whatever you do on one side of the equal, you must do on the other. So I'm going to add 8 to both sides of the equals to cancel out this minus 8 and the positive 8. So on the left, I'm just left with 4x. On the right, 8 plus 24 is 32. So now I have 4 times x equals 32. So I want to undo the multiplication of 4 times x, divide both sides by 4. On the left, I'm left with 1x, or just x. And on the right, 32 divided by 4 is 8. So x would equal 8. In B, again, don't let the fraction throw you off because that just means division. So what we have is n divided by 3 plus 6 equals a negative 8. So side with the variable, I have addition and division. I need to undo the addition first, so I'd subtract 6 from each side. So then n divided by 3 equals a negative 14 from the negative 8 minus 6 more. And then to undo dividing by 3, I would multiply each side by 3. So then 1n would equal a negative 42. And then in C, we have 6 equals 14 minus 2 times x. So now the variable's on the right. That doesn't matter. We just want to get it alone. So we have 14 minus 2x. This is the same thing as a negative 2x plus 14 if we rewrote it. But what we want to think to ourselves is, how do we get this positive 14 back to 0? So in this case, even though there's a minus here, that's in front of the 2x, this is a positive 14, so we want to get back to 0, so we'd subtract 14 from each side. So on the left, we have a negative 8 equals, and on the right, a negative 2x. Brought down the negative 2x that we didn't use. Now we'll divide both sides by the negative 2 to undo the multiplying, and x would equal a positive 4, because the negative 8 divided by negative 2. Now let's look at D, E, and F. So in D, we have 7 plus 2/3 multiplied by x equals a negative 1. So in this case, we want to undo the addition of 7, so we'll subtract 7 from each side. We have 2/3 times x equals a negative 8. Now, to undo the 2/3 times x, I'll be dividing by 2/3. But remember, if we're dividing by a fraction, we multiply by the reciprocal. So really, I'm dividing by 2/3 to get rid of this multiplication, but it turns into multiplying by 3/2 because dividing a fraction, we multiply by the reciprocal. So then in this case, the left-hand side is just x, the right-hand side, and -8/1 multiplied by 3/2. So -8 times 3 on top is -24. Divided by the 2 on bottom gives me a -12. In E, y divided by 4 minus 7 equals 13. So we have division and subtraction. Have to take care of subtraction first. To get the -7 back to 0, we add 7 to each side. So then we're left with y divided by 4 equals 20. To undo the division of 4, we multiply each side by 4, and y would equal 80. And then finally on this page, f. In f, we have y minus 7 all divided by 4, and that equals 13. So now if one whole side is a fraction, we need to get rid of that denominator first, because this would technically be y divided by 4 minus 7 divided by 4. So we multiply both sides by that denominator to cancel out the whole fraction bottom. So multiply both sides by 4, and it would be y minus 7 equals 52. And again, the reason we're undoing the division first is the whole side is a fraction, not just part of it like we saw in E. So multiply both sides by 4, that cancels the 4 on the bottom, and we have y minus 7 equals 52. Undo subtraction of 7, so add 7 to each side, and y equals 59. Now, this one says simplify the equation before you start solving. So what that means is if there's the distributive property or the chance to combine like terms, you do that first before we start to solve for the variable. So for example, in A, we have 3x minus 7 plus x. The plus x and the 3x can be combined. 3x plus x is 4x. So we would rewrite this as 4x minus 7 equals 5. Then we would start to solve by undoing the subtraction of 7. So add 7 to each side, and we have 4x equals 12. Divide both sides by 4, and x equals 3. In B, we have 3 times the quantity x minus 2 equals 18. So in this case, we have to use the distributive property first to simplify before we solve. So we'll distribute the 3 to each part of the inside. So 3 multiplied by x is 3x. 3 times 2 is 6, and we have subtraction in between. So 3x minus 6 equals 18. Add the 6 to each side, and 3x equals 24. Divide both sides by 3, and x equals 8. Now in C, we have to distribute and then check to combine like terms before we start to solve. So we have 5x plus 3 times the quantity, x plus 4 equals 28. So we'll distribute this 3, and we end up with 5x plus 3x plus 12 equals 28. 5x and 3x combine like terms to equal 8x. So 8x plus 12 equals 28. Subtract 12 from each side. 8x equals 16. Divide both sides by 8, and x equals 2. And then we have D, E, and F before our couple word problem examples. So same process in D, E, and F. We want to check to simplify and combine like terms before we solve. So in D, 4x minus 3 times the quantity x minus 2. So when we distribute, we'll be distributing a negative 3 to each part. So this becomes 4x minus 3x, and then plus 6, because the negative 3 times the negative 2 gave us a positive 6. Then 4x minus 3x plus 6, I got rid of the 6 from each side, and I'm left with 4x minus 3x equals 15. Combine like terms, and x equals 15. Could I have combined the 4x minus 3x before subtracting the 6? Yes, I could have. So it could have been x plus 6 equals 21. Subtract 6, and you still have x equals 15. In E, we're distributing the negative 6/5. So when I do that, the right-hand side becomes negative 6/5 x minus 18 over 5. I left both as a fraction. That way, when I'm undoing my subtraction, I'm just adding 18 over 5 to each side. So the 66, I need to have a common denominator with the 18/5. So I rewrote the 66 over 1 out of 5. So I multiply the top by 5. 66 times 5 is 330. So the 66 becomes 330 over 5 plus 18 over 5. That is 348 over 5 equals a negative 6/5 times x. So we'll divide each side by the negative 6/5, which is the same as multiplying by a negative 5 over 6. So then when we're multiplying the 348 over 5 times a negative 5 over 6, we can cross simplify where the 5's cancel, and we're left with a negative 1 and a 1. And then 348 can be divided by 6. So the 6 becomes a 1, 348 becomes a 58. 58 times negative 1 on top gives us a negative 58. And in F, we are technically distributing a negative 1 to each part inside the parentheses, because it's 5m minus the quantity 4m minus 1. So this negative gets distributed. So this becomes 5m minus 4m plus 1. So when we distribute the negative, it changes each sign inside the parentheses. Combine like terms, 5m minus 4m gives us 1m. So we're left with m plus 1 equals negative 12. Subtract 1 from each side, and m equals a negative 13. And then our last two examples. Example 4 says the Fahrenheit and Celsius scales are related by the equation degrees Fahrenheit equals 9/5 times our degrees Celsius plus 32. So use the formula to convert 95 degrees Fahrenheit to Celsius. So the 95 will take the place of Fahrenheit. So we end up with 95 degrees equals 9/5 times C plus 32. So we want to solve for C. So we'll subtract 32 from each side. And we have 63 equals 9/5 times C. And then we're going to divide by the 9/5. So 63 divided by 9/5, which is the same as multiplying by 5 over 9. And when you do the 63 times 5 over 9, you end up with 35 degrees Celsius. And then example 5. The temperature within Earth's crust increases about 30 degrees Celsius for each kilometer of depth beneath the surface. If the Earth's surface is 24 degrees Celsius, at what depth would you expect to find the temperature of 114 degrees Celsius? So I know it's 30 degrees for each kilometer beneath the surface. Surface was 24 degrees. We're trying to figure out 114 degrees for our depth. So first I want to figure out the change in the temperature from the surface to our depth. So 114 degrees minus the 24 on the surface tells me I changed 90 degrees. Then if I take the 90 divided by the 30 for each kilometer, I know that I went 3 kilometers deep into the Earth's surface, or into the Earth's crust. So the key for today's lessons go way back to just this beginning couple notes of using inverse operations. You want to think, how do you get the variable alone or isolate the variable? And you're working the order of operations backward to undo the mathematics.